Okay, we're going to go over the quiz as a part of the review for getting ready for the test. Right? You have a test on Wednesday, and then on Friday you have the benchmark. And on next Tuesday, that's the end of the 9 weeks. All grades have to be done. There's not going to be a lot of time after the test on Wednesday if you happen to need a retest. So, better don't fail. That would be the best idea. So I'm going to skip forward to the ones that we did here. Okay, solve equations by factoring. So for you guys, starts here. Oh, right there, right there. So this was your number one. What did you have to do first? No. We had a quiz that was over factoring, which many people tried to turn into solving equations by setting everything equal to 0. Now we have an a quiz on solving equations, which many people didn't solve the equation. You just factored it and then walked away from it. Kind of doesn't make sense. Okay, quiet. Go ahead. Yeah, so in this case, you got to add the 4x. 3x squared plus 4x plus 1 equals 0. So you had to take that step. Okay, it's important that either you make sure that 4x, when it comes over here, is in the middle, or you make sure that you have the b as whatever is the coefficient of x. Because there were some that put the 4x at the end and then wanted to say that like a is 3 and b is 1 and c is -4 or 4, which is not correct. Right, so this is the standard form. ax squared plus bx plus c. Okay, now how do we factor? That is the not simple. Right? You go 3 times 1 is 3. Right? What are the factors of 3 that add up to 4? 3 and 1. So 3x squared plus 3x plus x plus 1 equals 0. So we found those two numbers. We split up the middle term. Then what? Group the first two. Group the last two. And remember, there should always be a symbol in the middle where representing either plus for addition or minus for subtraction. Right? It's not a multiplying between those. Okay, then what? Greatest common factor. What's the common factor between these two? 3x. And what's left when I factor 3x from both of those? X plus 1. And then we've got x plus 1 in the other, which means we cannot factor it. But now we have the same thing in each set of parentheses. So what's the last step of factoring? Right. So now we have x plus 1 because it's in both sets of parentheses. And what's in this set? 3x plus 1. Right. And all of that equals 0. Okay, now we've got to do the solve for x part. Right? If this product equals 0, that means either this equals 0 or this equals 0. So if x plus 1 equals 0, what is the value of x? Right. So from this one right here, it should have been x equals -1. Okay, what about from the first factor? It should be x equals -1/3, right? Now, if you can't just see that, then make yourself a little equation. 3x plus 1 equals 0, and then solve it. 3x equals -1, x equals -1/3. Okay. All right, the next one we had another solve by factoring. This time, what kind of factoring? It's the greatest common factor. What is the greatest common factor? All right, so take a 6x from both terms. What's left in the parentheses? X minus 2. I use this problem with my other classes too, which are not Algebra 2 Trig. And I don't remember if you guys did this at all. I know in their classes there was a lot of factoring out of 6x and then still having a 6 inside. Right? But remember, you should be able to go backwards now do distributive property, and you should be able to get back to that expression. Okay, now, what are the answers? Okay, from this one right here, x equals 0. And from this one right here, x equals 2. Right? 2 minus 2 is 0, right? Or just this factor alone, if that factor has an x equals 0, then the whole thing's 0. Okay. Solve by factoring. What kind of factoring here? Difference of squares, right? So you got to always see one can be 1 squared, 1 to the third. We'll use it as 1 to the third in the next chapter. But so if it's x squared minus 1 squared, then how does that factor? X plus 1 times x minus 1 equals 0. And the answers are negative 1, positive 1. X equals negative 1, positive 1. Okay, what's your next one? Okay, this was your next one. Use the quadratic formula to solve quadratic equations with real and imaginary solutions. So this is actually going to be the imaginary solutions. But quadratic formula you were given, you just had to plug in. What was the value of b? 1. You don't see a number there, so it's 1. Okay, I don't think anybody actually had any problems with that. So we go x equals negative 1 plus or minus the square root 1 squared minus 4 times 4 times 5. Divided by 2 times 4. X equals negative 1 plus or minus the square root of 1 minus 80 divided by 8. Negative 1 plus or minus the square root of negative 79 over 8. Okay, how do we simplify now when we have the square root of a negative 1? It comes out as a 1. What is the definition of I? Right, I equals the square root of negative 1. So we take something like the square root of negative 79, and we split it up. That'll be the square root of negative 1 times the square root of 79. And the square root of negative 1 is I. That's at I times the square root of 79. So substitute it in here. Now we've got negative 1 plus or minus I times the square root of 79 over 8. Okay. What do you call the kind of numbers that have I in them? Imaginary numbers, right? What are complex numbers? Imaginary and real. Yeah, if you take all the real numbers, all the numbers that don't have I in them, and you put them together with all the imaginary numbers, all the numbers that have I in them, you get the set of complex numbers. That's the big set of numbers. Not that I know of. Well, I mean, you get up in higher math. I mean, they do things, where you've got like 9 dimensions, and it's very bizarre. I'm sure there's people out there that have played around with other, probably like, let's see what happens if we define another letter, let's call it J, is the 4th root of negative 1. And then they just see what happens when you do that. I mean, that's what mathematicians do at a high level. They do all kinds of games like that. Well, why? Okay. Some mathematicians are very proud to say that the things that they work on are not practical at all. It's all theoretical stuff. But even some of them are surprised later when somebody comes up with a practical use for the things that they did. Just to explore knowledge, right? They don't really know where it's going, but some people work like that. I mean, take somebody like Einstein. He's a theoretical physicist. But then he came up with things like the theory of relativity, which explains things like gravity. And, did anybody know he was heading in that direction? I mean, he learned things, we learned things from the theory of relativity that even Einstein didn't know were in there once he came up with the theory. I mean, when he came out, if you're just digress a little bit, there's two theories of relativity. In 1905, he came up with what's called the specific theory of relativity. And then in 1915, he came up with the big one, the one that E equals mc squared. And that one in itself, when he published it, it's a lot more than just that equation. People came to him and said, you know what this means? This means that the universe is expanding. And he looked back at everything. He said, well, I didn't mean to say that. And so he put in a little correction to the equation to make it not expand. Now we understand it expands. So people like that never quite know what they're going to come up with and how practical it might be. Okay, how about this one? Evaluate the discriminant only and use the result to determine the number of real solutions to a quadratic equation. Which part of the quadratic formula is the discriminant? Yeah, just this part here. Right? Do not, when you're asked that question, do the whole quadratic formula. It shows, again, that you don't really know what you're being asked for, because who would do all of that when you didn't have to, right? I mean, it does not even include the square root, which is the thing that introduces the most problems when we simplify. So just do this part. So in this problem, when you did it, you had b squared was negative 4 squared minus 4 times 1, which is positive 16 minus 16, which is 0. So the evaluate the discriminant part, that's the answer. The next part is, okay, what do we know about the number of real solutions because the discriminant equals 0? There's 1, right? Because, again, if you looked at this as the quadratic formula, the square root of 0 is 0, which means you're adding and subtracting 0 to get your two answers. Well, you're going to get the same thing both times if you do that. So, questions on quiz? Okay, let's go back to the beginning. Those I use those as part of the review, right, for those things. Now let's go back to the beginning to fill in the gaps. Some of this we actually just did in the homework, but I guess we'll go over them again. Write the equation of a function from its graph. And there's 2 pages this directs you to, right? I mean, we've been working with quadratics, which have the graph of a quadratic is called what? What is the name for the shape? It's a parabola, right? That's not a parabola. What function, again, makes this? It's an absolute value, v, okay? So when we have to write the equation, we have to go over here and say, okay, let's see, an absolute value function of which the parent function is the absolute value of x, but this one looks like it has been moved 5 to the right, 1 up, and flipped. Okay, how do you make that go 5 to the right? Where? Inside, right? So for this one right here, you would say f of x equals, and inside the absolute value, we've got x minus 5. That's what makes it go 5 to the right. What is it that makes it go 1 up? Plus 1 after, right? What is it that makes it flip so that it's going down? There's a negative before. And then there's one more thing that goes on, and that is either a stretch or a compression. And the way you check that, again, the absolute value of x is a v that has the slope on the left is negative 1, the slope on the right is positive 1. If you flipped it, then we would expect that's a slope of 1 and that's a slope of negative 1. But look what it's actually doing. When I go to the right of the vertex of that v, right, it's over 1, down 2. It's not down 1, it's down 2, which means that's a 2. Okay. What about this one? It's left 2, down 6. How do I write that? X plus 2 minus 6. Do I need a negative in front of it? Okay, does it look like it's got slopes of 1 and negative 1 for the sides of the v? It looks like I go over 1 to the right, and it's actually only up a half. So that's a half. So y equals. Right, that would be called a vertical compression. Right, these are the ones that we did for our homework last time, right? So now it's definitely the parabola shape, right? So we're starting with this, f of x equals x squared. And now I want to move this one 2 to the right and 5 up. What does that look like? Inside or outside? X minus 2 squared plus 5. Do I need a minus in front? Does it look like it's being stretched or compressed? I mean, look at, it's going over 1, up 1, the same as that, right? Because this one, what do you get when you plug in 1 or negative 1? You get 1. So this one is, no, there's no compression, so it's just like that. Y equals that. Let's see. Let's do the 36, because I don't think we did that one in our homework, because it was an even number problem. Let's see. What's the horizontal shift? What goes inside the parentheses? Plus what? X plus 1, right? It's left 1, so x plus 1. Okay, and it's down 3. Minus 3 here. It's opening up, so no minus. Does it look like it's being stretched? Yeah, instead of going over 1, up 1, it looks like it's over 1, up 2, so that's 2. So that be able to write an equation if you're given a graph, just by looking at the graph. And you're given 2 there. You're given the absolute value and the quadratic, because there will be one of both. Okay, describe the transformations. That's all you're being asked in this kind of question. So what is the transformation from the 2 out here? Stretch by a factor of 2. How about the minus 4? Right. How about the plus 8? Up. Oh, that's it. Right? It doesn't say graph, it just says describe. Okay, identify the vertex, the axis of symmetry of the parabola, and determine if the vertex represents a maximum or a minimum value. And notice that it's in the vertex form already. So you're not having to do the negative b over 2a or anything like that. Right? In this one right here, what is the vertex? 1, 2, right? The HK, the vertex, is 1, 2. What is the equation for the axis of symmetry? X equals 1. Okay. Does it have a maximum or a minimum? Okay. Because that's minus, that means that it opens down like that. So that point is the highest point on the graph. It's a maximum. Okay. And what about this one? The vertex is negative 3. Yes. Why is it not negative 1 over there? Because negative is just part of the equation. Where? Here? Yeah. Yes. Remember, it's x minus h squared. So the h is actually positive. If you don't remember it that way, think of it as a shift, right? Minus inside means right 1, up 2. So the coordinates at that point are positive 1, positive 2. Okay, so this one, the vertex is, right, negative 3, negative 4. What is the axis of symmetry? X equals negative 3. Okay, is that a maximum or a minimum? Since it's positive, the shape of the graph is like that, right? So it's a minimum. Min. Okay, and there will be one word problem, which is like the one we had in the homework. This one says a lighting fixture manufacturer has daily production cost of this equation. The cost equals 0.25 n squared minus 10n plus 800, where C is the total daily cost in dollars and n is the number of light fixtures produced. How many fixtures should be produced to yield a minimum cost? What are they asking for? Yeah, well, it says minimum, so they're asking for the minimum. specifically which one of the minimum is going to be HK, the vertex, but which one did they just ask for? How many fixtures would be produced to yield a minimum cost? They didn't ask for the minimum cost. They just want the H, right? So let's see. How do I calculate the H? Yeah, is negative B over 2A. So it's negative 10 over 2 times 0.25, which is 10 over 0.5, which is 20. So they should make 20. I think that's, no, they should make 20 to minimize the cost. And they didn't ask for the minimum cost, so don't calculate it. Okay, factor. These are coming from our first quiz. What kind of factoring do we do? This is, I guess it says it. If the A equals 1, it's a one-step process, right? You don't have to do the 1 times 100. You just look at the 100 and say, what are the factors of 100 that add up to negative 29? Right? 100, I mean, first of all, they're both going to be negative, right? They both have to be negative because the product is positive and the sum is negative, right? And so what were those two numbers? We did them before? Yeah, negative 25, negative 4. So one-step problem, x minus 25, x minus 4. That's it. Stop. Okay, greatest common factor, factoring. Remember, if you don't have 3 terms, then there's only 2 kinds of factoring that we've done that it could be. It could be a difference of squares, or it could be greatest common factor. This is the greatest common factor. What is the greatest common factor? It looks like there's a 3x in both terms, so we factor it out. What's left in the first set of x minus 11? All right, that's it. Stop. Remember, if you want to check it, then do distributive property and see if you get back to what you started with. 3x times x, 3x squared. 3x times negative 11, negative 33x. So it's got to be right. Okay, do the not simple. Again, I think we did one of these already in the solving equation, so I'm going to go through kind of fast. 2 times 15 is 30. The factors of 30 that add up to negative 13. Negative 3, negative 10. Remember, it's a positive 30, so they're either both positive or both negative, so it can't be 15 and 2. Right? So that is 2x squared minus 3x minus 10x plus 15. Right? I grouped the first 2 terms. I grouped the last 2 terms. Why did I switch the sign of 15? Because it's in parentheses and there's a minus in front of the parentheses. Right? So now I do greatest common factor factoring. I get x times 2x minus 3 and 5 times 2x minus 3. Right? So the last step is x minus 5 times 2x minus 3. Okay, perfect square trinomials. Remember, a perfect square trinomial is something that when you factor it, it's going to be the same linear factor squared. And you should recognize it because they recognize the first number as a perfect square and the last number as a perfect square. Right? So let's say 49, what is the square root of 49? So that's 7x and this is 9. Right? That's squared and squared. So since that's a positive number, we would expect maybe that's 7x plus 9 in parentheses squared. The only thing that has to check out is that middle term needs to be exactly that. So you could check it, just FOIL it, right? 7x plus 9 times 7x plus 9. Okay, it's too loud. Okay. So we need to check the middle terms. We know that the first term and the last term are correct if I FOIL these two. But I need to check if I get 126x if I do the middle terms. 7x times 9, 63x. 7x times 9 again, 63x. 63x plus 63x, 126. So that is the factoring. I mean, if you had a problem like this, if you couldn't factor it that way, you'd be thinking of doing 49 times 81. What are the factors of that number which add up to 126? That's pretty tough. But if you recognize it as a perfect square trinomial, it actually goes really quick. Okay. Factor difference of squares. I mean, you recognize it as a difference, right? A subtraction. 25 is a perfect square. 9 is a perfect square. So how does it factor? 5x plus 3, 5x minus 3. Right? Again, that's 5x squared minus 3 squared. Okay. Okay, so and there will be at least one, which is you got to have to do a combination of factoring, and almost always the first combination is first method, greatest common factor. I mean, if you didn't see this one as the greatest common factor first, then again you'd go 3 times 168, and you get some huge number, which is doable because a lot of you did it. This was the quiz question. But if you recognize that 3 is a common factor, first you take it out. And then you recognize that what's inside the parentheses could be factored again quite easily, right? What are the factors of negative 56 that add up to negative 1? X minus 8x plus 7. Done. 2 steps. Okay, we already did the solving equations. We did that one. We did that one. We did that one. We didn't do this one. This was the same one that we solved by factoring, but we'll do the quadratic formula just to show it working out with a real solution. The one I showed already had imaginary solutions. So again, we have to do this. 3x squared plus 4x plus 1. So it's in standard form equals 0. Plug it into the quadratic formula. X equals negative 4 plus or minus the square root 4 squared minus 4 times 3 times 1. Two times 3. So x equals negative 4 plus or minus the square root of 16 minus 12. Okay, so the fact that that's the square root of 4, which is a perfect square, tells you this was factorable. If we would have done it, it was factorable. So that is negative 4 plus or minus 2 over 6. So how do you simplify? How do you deal with the plus or minus symbol? You do it twice, right? You do this operation once with the plus and once with the minus. Right? The negative 4 plus 2 over 6 is negative 2 over 6, which is negative 1/3. The negative 4 minus 2 over 6 is negative 6 over 6, which is negative 1. Okay, we did that one. That was getting the imaginary solution. Again, remember, what is I? What's the relationship between complex, real, and imaginary numbers? We did talk about it. Okay, and then remember the difference between these two. In your homework, you had both these kinds of problems. First, you had the kind of problem which said, no, that's wrong. Evaluate the discriminant only. Use it to determine the number of real solutions to a quadratic equation. Then you had questions at the end of that which said, evaluate the discriminant and use it to determine the number of x-intercepts to the quadratic function. What was the difference between both of those? Remember, this is a function. It has a graph, right? So wherever it crosses the x-axis, those would be the solutions, the real solutions to the quadratic equation. And so it's the same question. It just, instead of asking for real solutions to an equation, we're asking for x-intercepts to the function. But it works the same way, b squared minus 4ac. Right? b squared minus 4ac. 10 squared minus 4 times 10 times negative 3. I mean, whenever you're solving a problem like this, and you notice that the c is negative, you know that you're going to have two real solutions. Because the b squared minus 4ac is going to have a minus and negative, which means everything underneath the radical is positive. So right away you understand that. That's 100 plus 120, which is 220. So how many x-intercepts do we expect? Remember, since that number is greater than 0, 2, right? If that was the problem I was asking you for, the solution, real solutions, when it's positive, you say 2. So 2 x-intercepts. Therefore, 2 x-intercepts. And that is that. So those are, every one of these, I had the problems up there with the description. What's posted on the website, or will be emailed, will have all the description of what you should be getting out of it. This is just putting together all those problems on one slide. So remember, you can do this for extra credit, hand it in before the test. If you fail the test, you can take a retest. Only if you did this and you handed in, got a full credit for it. So don't skimp on it. When you start missing whole pages that you don't even address, it's going to be hard. And understand the last day of the marking period is actually next Monday. We have to have our grades in Tuesday. Usually we have a few days. So I will grade this and have the results online like Wednesday. So if you look and see, I'll probably send emails home to let you know, you've got until next Tuesday to get it done. Yes. Wait. Okay. So that is that. You could work on this for the rest of the class. If you don't, I'm not going to say anything. Just make a mental note. So when your parents ask me why you don't